Right, 3 types of bonding. Yay! The sarcasm in my voice is very detected. Oh, this was from another series I did a long time ago. So, 3 types of bonding. What you need to know: Ionic, covalent, and metallic. Don't care about spelling. I have terrible spelling. It doesn't matter because I can do chemistry for some weird reason. So, ionic is most prominently between metals and non-metals. That bit's very easy to understand. Metals and non-metals, ionic bonding, very simple. It's simple maths. So a group 1 element has 1 extra electron in its outer shell. Group 2 have 2 extra electrons, so on and so forth, to 3 has 3, 4 has 4, 5 has 5, 6 has 6, 7 has 7, and 8 full outer shell, so that means they do not bond, basically. So basically, as you can see here, a atom needs to have 8 electrons in its outer shell, or 2 electrons in first shell. Yes, 8 electrons in the outer shell or 2 electrons in its first shell. So mostly group 1, 2, 3, so stuff like lithium, calcium, beryllium, sodium, potassium, that kind of stuff will always lose electrons, whereas stuff such as group 5, 6 and 7 elements, so that is iodine, etc., will always gain electrons. That's because they want a full outer shell. This is very self-explanatory. So how does this happen? So let's say there's an atom, and inside this atom there is that, and inside, okay, let's just say there's that, there we go, there's the inside bit, and that one has 2 electrons inside of it. So that is a group 1 metal. Then let's just say there is this, which has that, and we don't need to draw the inside electrons, we'll just draw this. So 1, 2, 3, 4, 5, 6, 7. So this is a random group 7 element, this is a random group 1 element. So as you can see here, this has 1 electron which needs to leave, so this becomes happy. So right now it's sad. To become happy, it needs to lose this 1 electron. So what happens is this yeets over to here. So that makes this element happy as well. So now this element's happy, and this element's happy, thus making everyone happy. And by doing this, an electron has a minus charge, so a charge of -1, and protons have a charge of +1. So when this group 1 element loses an electron, it means that it has 1 more proton than an electron, thus it becomes positively charged. Whereas this now has 1 more electron than it does proton, so it becomes negatively charged. So the proper terminology, the proper way of writing this would be in curved brackets and be -1 to connote the bonded element. So that is ionic bonding. So covalent bonding, this is between non-metals, a process of sharing electrons. This makes them form compounds. So so basically, let's say we have this element right here. It's a group 5 element, so it has 1, 2, 3, 4, 5 and let's say here we have a group 7 element, so it has 1, 2, 3, 4, 5, 6, 7. So this element has 5, whereas this element has 7. So they both want to be happy, so they both want a full 8 electrons. So this will combine together, so they combine, and in an overlap, so kind of like a Venn diagram, so like that and that in a way. In this bit, there will now be some simple maths. So 1, 2, 3, 4, 5, so it needs 3. So here, you will draw 4, because this is also going over here, but this one needs 8. Thus, if you were to do this, it would be 1, 2, 3, 4 there, and then there would be 4 around the out here and 4 around the out here. And that is literally covalent bonding. It is the process of sharing electrons to make two people happy. Good job. And now it's time for metallic bonding. This one is... I've never actually understood the purpose of this. It isn't exactly... Is it... You don't really need to know about the bonding in a way. You kind of just need to know about a specific phrase, and that's it. That's all the exam questions I've ever seen. So this is a metal. First of all, different shapes. Different shaped atoms. They're not the same size. Secondly, electrons. These are delocalized, which means they can move. And that is why they can conduct electricity. Yay! And finally, because we know electrons, metals are malleable, so they can move very easily over each other. That's because these are arranged in layers, which means that these can easily slide over one another, thus being able to move very easily. They can also move, well, vibrate quite well in their positions, thus being able to conduct heat as well. So these always have delocalized electrons, and that's why metals can conduct electricity so well, because they have these delocalized electrons involved, whereas most non-metals don't have these, but they don't really bond like this. They instead bond with covalent or ionic bonding, and that is literally the 3 types of bonding you need to know. It's very easy. It isn't really anything to get your head around. It's just easy. Full stop. Peace.